Now let's look at solving rational inequalities. These are going to be the same way as we solved the polynomial inequalities, except for instead of finding the zeros, we're going to find the zeros and the vertical asymptotes. We're still going to use the open or rounded parentheses if we have less than or greater than. And if we have less than or equal to or greater than or equal to, we'll use the square parentheses or the included parentheses. Now this is unless you have an endpoint being a vertical asymptote, because if it's a vertical asymptote, we can't actually touch that number, so we'll go back to using the rounded parentheses there. Let's look at our first example of negative 2 divided by 2x minus 5. In finding the zeros, if we set that equal to 0 and try to solve, you will notice that we'll need to multiply both sides by the denominator of the fraction of 2x minus 5. That will clear the fraction out. That's going to make the right side or the left side of the equation just a negative 2, and the right side will be a 0. Notice that negative 2 is not equal to 0, and our letters dropped off. Since this is false, there is no solution or no zeros in this problem. There is, however, going to be a vertical asymptote. Because we have a fraction, the denominator of that fraction cannot be 0, so 2x minus 5 is not allowed to equal 0. If we add 5 to both sides, 2x is not going to be allowed to equal a positive 5. And when we divide both sides by 2, x is not going to be allowed to equal 5 halves. That's your domain, and your vertical asymptote is going to be actually at x equals 5 halves. So we're going to put that on a number line. There are no zeros, but we can go ahead and put our vertical asymptote on there. 5 halves is going to be 2.5, so we'll have a vertical asymptote here at 2.5. We're going to solve this the same way we solved the other one. I'm going to take a test point to the left of the vertical asymptote. I'm going to use the actual value of 1, plug it in the original inequality, so that will be negative 2 divided by 2 times 1 minus 5. That's going to be a negative 2 over 2 minus 5. A negative 2 over negative 3 turns out to be a positive 2/3. Notice that that is going to be positive, so this region is going to be positive. Doing a test point on the other side, I'm going to choose the value of 3. Plugging that into our original inequality is going to be negative 2 over 2 times 3 minus 5. That's going to be a negative 2 over 6 minus 5. A negative 2 over a positive 1 is going to be a negative 2. So this whole region of the number line is going to be negative. Our original inequality asked, where is this going to be less than or equal to 0? Where is it going to be negative? And we will say from the 5 halves to positive infinity. Now, even though this was an equal to sign, since this is a vertical asymptote, we're always going to use a rounded parentheses there. And of course, the infinity is always going to get the rounded parentheses. If we look at that one on the calculator and go to our y equals screen, type in the function. Remember, if you're using an 83, these rational functions need to be graphed in the dot mode. A little bit easier on the 84s. If I can get this calculator to work. Going to the y equals, typing in a negative 2 divided by the quantity of 2x minus 5. And again, if you're using an 83, come over here to the left side of the y equals, make sure that's in dot mode before you graph, and look at that picture. We notice that it will show that we have a vertical asymptote at x equals 5 halves. Where is this less than or equal to 0? Well, it's from 5 halves to positive infinity. Let's look at another example. where we have x plus 1 divided by x plus 2 is greater than 0. To find the zeros first, we're going to set that rational expression equal to 0. We're going to solve it. We're going to clear the fraction by multiplying both sides by the x plus 2. That will clear the fraction on the left-hand side, leaving us with just an x plus 1. 0 times anything is going to be 0. Subtracting 1 from both sides, our 0 is actually going to be x equals negative 1. This one also will have a vertical asymptote. If we look at the domain, bottom of the fraction cannot equal 0, so x plus 2 is not going to be allowed to equal 0, and x is not going to be allowed to equal a negative 2. Therefore, you're going to have the vertical asymptote at x equals negative 2. Let's plot both of these numbers on the number line. You have a 0 actually at x equals negative 1, and we're going to have the vertical asymptote actually at x equals negative 2. We're going to divide the number line into 3 equal sections and do some test points. A number in the first region or to the left of the asymptote is going to be negative 3. If I plug that into my original problem, I'm going to have a negative 3 plus 1 over a negative 3 plus 2. That's actually a negative 2 divided by a negative 1 or a positive 2. So this region is going to be positive. I need to find a test point in between negative 1 and negative 2. So I'm going to use the test point of negative 3 halves. That's negative 1.5. If we do negative 3 halves plus 1 over negative 3 halves plus 2, that's going to be a negative 1/2 on the top. Then it's going to be a positive 1/2 on the bottom, which will end up being a negative 1. So this middle section is going to be negative. Choosing a test point to the right of the 0, I'm going to use 0. So 0 plus 1 over 0 plus 2 is going to give us a positive 1 over a positive 2, or a positive 1/2. The original problem says, where is this greater than 0? So where is this positive? That's going to be from negative infinity to negative 2, not including the negative 2, because we do not have an equal to bracket. That's also an asymptote. And it's going to be also from negative 1 to positive infinity. So we'll union those two sets together. If we looked at this on the calculator, go to your y equals, type in your original function, remembering to use parentheses around the top and the bottom because it's more than one term. So x plus 1 divided by the quantity of x plus 2, and look at that picture. If we're asked, where is this greater than 0, where is this above the x-axis, we'll see that it's above the x-axis in this first region from negative infinity to negative 2, and it's also above the x-axis once it crosses this 0 of negative 1 going to positive infinity. Good luck on this homework.